Welcome to our channel Electrical and Electronics Engineering. Today here I am going to discuss about how to do proper cable sizing. There are three criteria for sizing of cable: calculation of ampere capacity, calculation of voltage drop, calculation of short circuit current. Here I divide the total video into two parts. In the first part, it is shown calculation of ampere capacity, calculation of voltage drop. In the second part, it is shown calculation of short circuit current. Now we are going to discuss ampere capacity of cable. Cable is having base current capacity based on its cross sectional area in square mm. But based on installation, it consumes some derating factor of its base currents, that is called ampacity rating of cable. There are two types of installation: underground installation and above ground installation. Underground installation and above ground installation. In underground installation, correction factor of ambient temperature is equal to K1, correction factor of soil resistivity is equal to K2, correction factor of depth of cable laying is equal to K3, correction factor of grouping of cable together is K4. Correction factor of ambient temperature is equal to K1 in above ground installation. Correction factor of grouping of cable is equal to K2. Grouping of cable are of two types. With cable touching to each other, here all the cable touch to each other, and with spacing between cables equal to diameter of cables. Here the cable diameter D and the spacing is between cable D. Okay. Assumed rating factor for XLP cable in air at ambient temperature 40 degrees centigrade is equal to 1. At ambient temperature 45 degree centigrade is equal to 0.94 is equal to K1. Group rating factor for cable touching each other is equal to 0.75 is equal to K2. So derating factor for XLP cable in air is equal to 1 into 0.75 is equal to K1 into K2 is equal to 0.75. Again, assumed rating factor for XLP cable laying underground. Rating factor at ambient ground temperature 40 degree centigrade is equal to 1 is equal to K1. Rating factor for soil thermal resistivity at 150 degree centigrade centimeter per watt is equal to 1 is equal to K2. Rating factor for depth of laying 900 mm depth is equal to 1 is equal to K3. Group rating factor is equal to 0.75 for cable touching each other is equal to K4. So derating factor for cable underground is 1 into 0.75 into 1 into 1 is equal to K1 into K2 into K3 into K4 is equal to 0.75. All the values you will get from cable manufacturer datasheet. Calculation for cable cross section size by using derating factor. Assume load current is equal to I1. Then divide it by calculated derating factor of air for the current value I2 is equal to I1 divided by K1 into K2, or divide it by calculated derating factor of underground for the current value I2 is equal to I1 divided by K1 into K2 into K3 into K4. Here I2 is equal to K1, I2 is equal to I1 divided by K1 into K2 into K3 into K4. Then choose the cross section of the cable for the current I2 from the cable manufacturer datasheet. Example, assumed a three-phase motor of 100 kilowatt operated from 415 volt at 0.9 power factor and 0.9 efficiency. Then current of motor is 100 into 1000 divided by root 3 into 415 into 0.9 into 0.9 is equal to 171.75 ampere per phase. Now divide it by derating factor for air, we get 171.75 divided by 0.75 is equal to 229 ampere per phase. Now choose the cross section of cable for 229 ampere from table, which is 120 square mm, 3 core 1.1 kV XLP aluminum cable. Okay. Calculation of voltage drop of cable. Voltage drop calculation of incoming cable of 100 kilowatt motor at power factor 0.9 and efficiency 0.9. There are two types of voltage drop for motor cable. A voltage drop at running VDR, which is less and equal to 3%. Voltage drop at starting VDST, less and equal 15%. VDR is equal to root 3 I full load into within bracket r cos theta plus x sin theta bracket close into L. L means length of cable in meter divided by V rated into 1000 into number of run. Number of run means parallel cable into 100 is equal to equation 1, where VDR voltage drop at running condition, R is equal to resistance of 120 square mm aluminum cable at 90 degree centigrade 0.325 ohm per kilometer. X is equal to reactance of 120 square mm aluminum cable is equal to 0.072 ohm per kilometer. Value of R and X you will get from cable manufacturer catalog. L is equal to length of cable in meters, say 100 meter. IFL full load current 229 ampere. V rated 415 volt. Cos theta power factor at running condition 0.9 and sin theta 0.43. Putting all these values in equation 1, we get answer 3% VDR, which is less uh, less and equal to 3% for 120 square mm cable. That satisfied our requirement. VDST. VDST, where VDST voltage drop at starting condition, which is root 3 into 6 into I full load into 1.2 within bracket R cos theta plus X sin theta bracket close into L. L means meter of cable in length divided by V rated into 1000 into number of run. Number of run is parallel cable into 100 is equal to equation 2. That is equation 2, where VDST voltage drop at starting condition, R is equal to resistance of 120 square mm aluminum cable at 90 degree centigrade 0.325 ohm per kilometer. X reactance of 120 square mm aluminum cable 0.072 ohm per kilometer. Value of R and X you will get from cable manufacturer catalog. L is the length of cable in meter, say 100 meter. IFL at starting 6 times of full load current of 229 ampere. Uh, 1.2 is margin factor. V rated is equal to 415 volt. Cos theta is equal to power factor at starting condition 0.3, and sin theta is equal to 0.95. Putting all this value in equation 2, we get, here is equation 2, we get answer 11.4% BD, which is less equal to 15% for 120 square mm cable. This also satisfied our requirement. If voltage drop result are not satisfied after calculation, then we have to increase either cross section or the number of parallel run of the cable to decrease the voltage drop. That is all for part 1. If you think that the video is useful to you, then please subscribe our channel, and in the next video, part 2, I shall discuss about the short circuit current of cable and manufacturer catalog, datasheet, etc. Okay, thank you. Bye.